Hello again. This video is going to follow up our first video on introducing the exponent rules. This time we're actually going to apply them to some complicated expressions. So we're going to start with a slightly easy one that looks similar to the first video. And I'm actually going to expand this one to show you that if you ever forget an exponent rule, you can always go back to the technique we learned to develop the rules. Okay, so xy squared raised to the fifth means I'm multiplying this base 5 times. So it's xy squared to the fifth times xy squared to the fifth times xy squared to the fifth, and I'm going to keep going for 5 times. Okay, now I'm going to rearrange these so I can group x's with x's and y's with y's. So let's see, I have 1, 2, 3, 4, 5 x's, 2, 3, 4, 5, and I also have 5 y squareds. Y squared, 3, tedious, but it works, right? Okay, now I want to rewrite this using exponents, but wait, we already have some exponents left, so maybe I'll simplify this more. I have 2 y's in each of these. This way we can just count. It makes it nice and easy, even though it's tedious. Okay, so how many x's do I have? The answer is 5. Now how many y's do I have? Well, I have 2 y's 5 times. That means I have 10 y's. So that would be the entire expression simplified. The reason exponent rules are so wonderful is because this took us a long time, and the exponent rule takes a very short time. So this is when you have 2 different bases raised to a power. So this is the expanded or distributed rule, where all I have to do is distribute the 5 to both bases, the x and the y. In order to do this, we need to remember what the exponent on the x is. Okay, I always throw in something like this because I know people forget it. So how many x's do we have here? The answer is 1. So now all you have to do is multiply the exponents. So it's x to the first. 1 times 5 is x to the fifth. Now we have y to the second. 2 times 5. Our exponent is y to the 10th. See how much faster that is? Isn't it great? Let's try another slightly easier problem. This time I'm only using exponent rules. So we have a bunch of different bases. We have a 2, an x, a 3, an x. Think of each of these as their own base. Okay. I'm really multiplying 2x 4 times, 3x to the third 4 times. That means I'm multiplying the 2 4 times, the x 4 times, the 3 4 times, so on and so forth. So right now we have 1 2, we have 1x, we have 1 3, we have 3x cubes. Okay, so anytime you have different bases, even if it's division, and it's all multiplied to the fourth, that means you would multiply this whole thing 4 times. So we can distribute that 4 to each base. So we have 2 4 times and x 4 times in the numerator. We have 3 4 times, and this one's a little tricky. You got to multiply the 3 and the 4, so we have 12 x's in the bottom, the denominator. Now, one of the most commonly missed things in exponent rules is forgetting to distribute to the numbers and giving me this. But if you remember how we derived this rule, you would have to expand 2x 4 times. That means we have 2 4 times as well. So do not forget to distribute to numbers or coefficients as well. Okay, now all we have to do is simplify and we're good to go. So 2 to the fourth, that's 2 4 times, gives us 16x to the fourth. And 3 to the fourth, that's 3 times 3 is 9, times 3 is 27, times 3 again is 81. And x to the 12th is already simplified. If you wanted, before I simplified it here, I could have written this as x to the third to the fourth, or you can just go ahead and multiply. The last step would be to see if there's anything you can cancel between 16 and 81. So you can't divide 81 by 2. Can we divide 81 by 4? No, you can't do that. I don't think there's anything we can simplify, but if there was, you should. And that would be my final answer. Moving right along to some uglier problems. There's nothing you can't handle if you don't use, or if you do use your exponent rules. So we have 20, and we have x to the third raised to the fourth. So this, we have one base, the power raised to another power. What do you do with those exponents? You multiply. So anytime you see that, you're going to multiply these exponents. I'm going to start with that. You can start in any order you choose. So we have 20, and then we have x to the third, and it's raised to the fourth. That 4 only goes with what's in the parentheses, not the 20. So power to a power, you multiply. That would give us x to the 12th. Okay, another power to a power here. We have negative 2 and 5. So multiply those, you get negative 10. And that takes care of the numerator. Same thing in the denominator. This negative 3 only goes with what's in parentheses. So that's 8, and 2 times negative 3, power to power, gives us negative 6. And one more power to power gives us y to the 12th. Now, here you can go in different orders. You can combine like terms, or you can take care of negative exponents first. My advice would be to get rid of any negatives you see. So this negative exponent and this negative exponent. Remember, back to your rules, anytime you have a negative exponent, it switches its position. So this one will come down here, while this one will come up here. When you flip them, we get a positive exponent, which is what we want. So now this will be 20 x to the 12th, and this x to the 6th will flip to the top. Nothing left there because the y to the 10th is going to go down. So now we have 8, y to the 12th was already there, and now we get another y to the 10. Last up, we have some x's and we have multiple y's. You need to combine those. We should only have one x base and one y base at the end of our expression. So in order to do that, this time you have the same base and you're multiplying those together in both situations. So when you multiply, what do you do with the exponents? If you remember back to the video, we're going to add them. So x to the 12th times x to the 6th, we're going to add those together. 12 plus 6 will give us 18. Same thing here, except our basis is a y. So we're going to add those and you get y to the 22nd. If you could simplify anything here by dividing, you should. But why can I not? And it's because you have an x and a y, they're not common bases, so you can't simplify those together. But you can simplify the 20 and the 8, so just by rules of fraction, we should go ahead and do that. What common factor can you take out of both? I know we can take out a 4, and I believe that's the biggest thing. So divide each by 4, and your final answer will be 5 x to the 18th over 2 y to the 22nd. Again, just a reminder, if I'm going too fast, go ahead and pause, write down questions, do what you need to do. Number 4, a little bit different because our coefficients are on the inside, not the outside. But remember, exponent is repeated multiplication. So we're going to multiply all of this 5 times. We're going to multiply all of this 2 times, all of this 3 times. You get the idea. Okay, so anytime you have an exponent on the outside, you're going to distribute to every term on the inside. This 2 is its own term. This x to the 3rd is its own term. So what's the exponent on the 2? I find it helpful to write these in. We have 1, 2, 3 x's, 1, 6, negative 1, 2. Okay, this 4 has only 1, and this 3 is only 1. Everything else is written in. Okay, so you're really multiplying the negative 2 5 times as well if you think back to expanding. So I can distribute this exponent and make it negative 2. 1 times 5, well, I have 5 negative 2's. Okay, then this would be x to the 3rd, and I'm actually going to write this out this time. X to the 3rd to the 5th. That's my first. Okay, next expression, well, we have 6 2 times, so 6 times 6, or you really have to distribute that 2. 2 times 1 gives us 6 squared. Okay, then we have x to the negative 1st. You'll distribute that, and we have y squared, squared again. Okay, same thing in the denominator. We have 4 3 times, x to the negative 2nd 3 times, and on this side we have 3 3 times, 3 times 1, and we have y to the 4th 3 times. Now this time I actually wrote it all out, whereas I didn't before, because if you are someone who makes mistakes a lot, it's good to write out your steps. Okay, so now I can go back and do power to power, I multiply. So like that 3 times 5, I'll multiply this and make it 15. So negative 2 to the 5th. Now, do I have to flip this negative 2 to the 5th? The answer is no. The only time you flip is when the exponent is negative. What negative 2 to the 5th means is you're multiplying negative 2 5 times. And there's nothing wrong with that. You can multiply negative 2 5 times. Don't flip. So positive 2 to the 5th would be 32. Okay, but if you multiply negative 5 times, well, negative times a negative is a positive. But if you do it an odd amount of times, it's going to be a negative. So you get negative 32. X to the 3rd to the 5th would be giving me x to the 15th. Okay, 6 squared is going to give me 36. This will give me x to the negative 2 when I do power to a power. This will give me y to the 4th. There's my numerator. Okay, denominator, 4 to the 3rd will give me 64. Power to a power, you multiply. Negative 2 times 3 is negative 6. 3 to the third is 27. Y to the fourth to the third, we're multiplying y to the fourth 3 times, so we would wind up having 12 y's. Power to power you multiply. Now I'm being repetitive, but must be important then, right? Okay, so this is still kind of ugly. You need to make sure at the end we only have one x expression, one y expression, instead of having two x's and two y's. We should only have one number in the numerator, one number in the denominator. Remember from our first video that multiplication is commutative, which means you can multiply in any order. So what I want to do is multiply things by what they're similar to. So let's start by multiplying 36 times negative 32. So 36 times 32 will give us 1,152. And it'll be negative because you're multiplying negative times positive. Okay, in the numerator, you also have an x to the 15th and an x to the negative second. Okay, so remember, when you multiply, you have the same base, you add the exponents. So 15 and negative 2 will give me 13 x's. And then we only have one y in the numerator, so we'll leave that alone for right now. Now, I just want to point out, I just took care of the numerator first. That's my suggestion. However, there are other ways to do it. Technically, I could simplify these two x's together first. I could use the quotient rule, but I didn't. So it's up to you, but that's my advice. All right, let's deal with the denominator alone, and then we'll clean it up even more. So first what we want to do is we want to multiply 64 times 27. 64 times 27 gives me 1,728. Okay, now we don't have any common variables, so I'm going to leave this as x to the negative 6 and y to the 12. Again, I like to clean up just the numerator, just the denominator, because really, if you ignore all of this for 1 second, the numerator is its own problem. Same with the denominator. Okay, now there's still multiple x's and y's, so I'm going to go ahead and combine these, and then I'm going to go ahead and combine these using my quotient rule. Quotient meaning division. Okay, so anytime you divide, remember you subtract the exponents. So this will be x to the 13 minus a negative 6. Okay, so what's 13 minus negative 6? That's really like adding. So that'll give us x to the 19th. And that goes to the numerator. Okay, the other thing you could do if that doesn't make sense to you, remember this is a negative exponent, you can bring it to the numerator. So what I'd really have in the numerator is x to the 13th times x to the positive 6, which would still give me x to the 19th. Sometimes that makes more sense. Up to you. Okay, now I have y to the 4th divided by 12, so I can subtract those exponents. And that'll give me y, well what's 4 minus 12? It's going to give me a negative 8. Okay, so anytime you do that quotient rule, they go to the numerator. Now I'm going to fill in my numbers. We'll simplify those in a second. All that's left in the denominator is 1,728. Okay, now again, there's multiple orders you can do things in, but there's a negative exponent. We don't want that. So now this goes to the bottom. And if you think about that, it makes sense because there were more y's on the bottom than the numerator. Okay, so if you canceled, everything would be gone from the numerator and there would be 8 left on the denominator. Okay, so if you want to just think about it that way and put it right on the bottom, that's okay too. But I know a lot of people get confused, so I'm going to do the rules as they are told. So last thing would be to simplify these numbers, which you can do on your own, because I don't have that function in my calculator right now and I'm getting a little bit lazy. I'm just going to write out the final answer without simplifying those. So y to the 8th goes to the denominator, and this is our final answer. Okay, this one requires a lot of exponent rules, and there's a lot of different orders you can do it in. You may even want to try this problem on your own, even do it in your own way if there's a different order you like. But if you can do this one, you're pretty good to go. So as always, come to class with questions. I hope you learned a lot, and see you later.